Hiya, it's Mr. Baker here, and today we're going to be looking at forces and braking, and in particular stopping distances. So this is what we're going to be looking at today, forces and braking, and this is a question we'll try and answer: why do we have speed limits? Speed limits are an important part of road safety. They aim to prevent drivers from driving at speeds that are unsuitable and unsafe. The speed limit of a particular road depends on a range of factors, such as how straight or curved it is and its location. The faster a vehicle is driving, the longer it will take to stop. The overall distance this takes is called the stopping distance. And the stopping distance of a vehicle equals the thinking distance plus the braking distance. Now we're going to look today at the factors that affect the stopping distance, and to do that we need to look at what are the factors that affect the thinking distance and what are the factors that affect the braking distance. So stopping distance of a vehicle equals the thinking distance plus the braking distance. The thinking distance is the distance a vehicle travels in the time it takes for a driver to react to a situation and apply the brakes. So what factors do you think might affect that? You might want to pause the video here and just think of anything you can, and I'll go through them. Okay, here we go. So what factors will affect thinking distance? So there's a few. What factors will affect thinking distance? So alcohol. So if you drink alcohol, then that might slow your reaction. So that might mean that you will take longer to react to putting your brakes down. Some other drugs and some other medicines will have the same effect. If you're tired, your reaction time might be slower than normal. If you've got distractions such as mobile phones and things like that in the car, then that can also increase your reaction time, and that will increase the thinking distance. And the speed. So even if you're quite alert and your reaction time is quite good, then if you're going faster, the faster you're going, the further you'll go in that time. Okay, so it's all to do with the distance you're travelling while you're reacting to putting your foot down on the brake. Normal reaction time might be about 0.2 seconds, something like that. So anything that increases your reaction time will increase the distance you'll travel while you're thinking about stopping, and that's the thinking distance. Okay, so what about the braking distance? So you've put your foot on the brake pedal. So what factors will affect how long it takes for your car to stop then? Again, you might just want to pause it there, see if you can think of any. And I'll go through them now. So what factors will affect braking distance? So there's a few again. So not necessarily specifically the weather, but anything that can reduce the friction of the road. So if it's means that it's raining and so the road's wet, then that's going to reduce the friction. If it's icy, then it's going to reduce the friction. The conditions of the tyres or brakes, so the same kind of idea. If you haven't got a condition of tyres or your brakes aren't in very good condition, then that's going to reduce the friction between either the brakes and the tyres, or the brakes and the wheels, and the tyres and the road, and that's going to increase the distance you'll travel while you're braking. The condition of the road, again, similar idea. If it's gravelly or something like that, that might affect how far you'll go while you're braking. And again, the speed, the faster you're going, the further you will go before you stop after you've pressed the brake. Okay, so how do these factors affect the changing in distance? So the thinking distance, if you increase the time, that will be directly proportional to how much thinking distance is increased. So whatever increase you have in the time, that will directly link to the distance you're travelling. Increasing the speed will also be directly proportional to the increase in the thinking distance. So basically increasing the time or increasing the speed will be directly proportional to the distance that you will be travelling further because of the increase in the thinking distance and thinking time. How about braking distance? So there's a few factors. So we could use F equals ma to find the braking force on a vehicle if we know the mass of the vehicle and the deceleration while braking. If we then assume that the deceleration is constant, we can use the equation. This is the equation of constant acceleration. A equals v squared minus u squared divided by 2s. Remember, a is the acceleration, v is the final velocity, so that would be 0 if you're stopping, u is the initial velocity, and s is the distance you would travel. To find the braking distance, if we know the initial speed, the final speed is obviously being 0 there. The faster you can transform kinetic energy into heat energy, the more efficient your brakes are. So the smaller the friction is, the larger the braking distance. And since kinetic energy equals a half times mass times speed squared, the braking distance is directly proportional to speed squared. Now, there's an awful lot there, and it's not easy stuff either. The equation for constant acceleration, you don't need to remember that one, but you do need to be able to use it. You can see though that all of these things are really good revision of lots of different topics that you've done before. So energy, kinetic energy, is something you will have done from the P1 part of the paper, of the exam. So you'll have done that before. You've looked at constant acceleration equation, and you've looked at forces, you've looked at Newton's second law. So you can see that it's a good revision of all of these different things that you've done before. And so if I now show you on a speed time graph or a velocity time graph what that would look like. So this is the graph of a car stopping. And we know that from a speed time graph, the area underneath the line of a speed time graph equals the distance you've travelled. And we've got two portions to this graph. We've got the first portion here where we're travelling at a constant speed. And then we've got this section here where we're decelerating to nothing. And so we're decelerating to nothing. If our speed's nothing, then we've stopped. Okay, so this point here, this section here, up to this time here, we're travelling at a constant speed. So this is the moment at 0 here. This is the instant that I see something in the road that I've got to stop for. And so I'm thinking. Here I press the brake. And as soon as I press the brake, my car slows down. My car slows down at a constant amount, so it's like a constant deceleration until I stop. Okay, so we could find out the thinking distance by working out the area of this rectangle, and we could find out the braking distance by working out the area under this triangle. So this would just be the reaction time times the speed to find out the thinking distance, and to find the braking distance, it would be this time between as soon as I've touched my brake from the reaction time to the time it takes me to stop, half that, because it's half times base times height, so half of that times the speed, and that would give me the braking distance. And we know then that the stopping distance equals the thinking distance plus the braking distance. Okay, so I've written it down here. The thinking distance equals the initial speed times the reaction time, and the braking distance equals half times the time taken to stop once the brakes have been applied, multiplied by the initial speed. Okay, so what can you do? That's pretty much the end of this lesson. So what can you do? I can describe the factors which affect the stopping distance of a car and predict their effects on stopping distance. You can also calculate the thinking distance for a car from the initial speed and the reaction time. You can describe the velocity time graph of a vehicle stopping and apply the equation for uniform acceleration to the deceleration of a car. And there's other things as well that we looked at in that lesson. And ultimately we looked at this question, why have speed limits? And it's all down to the fact that we're talking about safety, and if we're going faster, the faster we're going, ultimately the further we'll go, the further the total stopping distance will be. Right, well that's the end of that one. I've been Mr. Baker. Thanks very much, and I'll see you next time.